This is a video lesson on biofuels. Biodiesel synthesis will be used as a case study, and we will be making and testing biodiesel to check for its efficiency as an alternative fuel source. This lesson assumes the audience has a basic understanding of general chemistry and thermal energy concepts. It also includes basic organic chemistry concepts as they relate to fuel sources. Narration and development of this lesson plan was done by Derek Spencer and is a product of the NSF-funded Boat of Knowledge in the Science Classroom projects at Ohio University. What are fuels? Most of us are intimately familiar with the use of petroleum products as fuel in our vehicles and machinery. All of our infrastructure is based around the use of personal vehicles for transportation, which would not be possible without the help of gasoline. While gasoline is probably the most recognizable type of fuel, it is important to understand that it is not the only useful one. A fuel can be defined as any material, liquid, solid, or gas, which stores chemical potential energy and can be used in some way, shape, or form as a source of energy. By this definition, wood actually classifies as a fuel source. We can use the burning of wood as an example. The heat you feel from a fire is due to the chemical energy being released by the combustion of wood in the presence of oxygen. The wood will continue to burn until all of the chemical energy is expended, or until the temperature is no longer able to sustain the reaction, at which point heat is no longer given off and the fire goes out. Can you reignite the ash at the bottom of a fire pit? The burning of wood is probably the earliest example of humans utilizing a fuel source for their own benefit, and is also an example of a biofuel and renewable source of energy. Take a minute and see if you can come up with other examples of fuel. Try to separate your suggestions into what you might consider conventional fuel and biofuel. By the end of this lesson, you should understand what biofuels are and how they compare with traditional petrol fuels. In order to understand biofuel and other fuels, a little bit of organic chemistry goes a long way. Organic chemistry is any chemistry which involves the carbon atom. Because of carbon's unique ability to bond with 4 other atoms, it is present in all forms of life on Earth. When a molecule is comprised entirely of carbon and hydrogen atoms, it is called a hydrocarbon. Typically, hydrocarbons make excellent fuel sources. They are relatively stable in long chains, are abundant in nature, and easily combust to carbon dioxide and water, which are stable end products. When combusted, hydrocarbons release a net amount of energy, which can then be utilized to generate energy in the form of work or heat. You may already know about methane, ethane, propane, and butane. These compounds are known as alkanes, with methane being the simplest example. Alkanes are saturated carbon chains, meaning all the carbon-hydrogen and carbon-carbon bonds are single bonds. Methane, ethane, propane, and butane are all gases at room temperature and are all used as sources of fuel. Alkanes with more than 4 carbon atoms are typically liquids or solids at room temperature. The higher the carbon content, the more likely the alkane is to be a solid or liquid. Another important class of hydrocarbons present in fuel are aromatics. These are cyclic hydrocarbons with a ring-like structure and are highly flammable and stable. They are toxic compounds and are persistent in the environment due to their stable structure. A few examples of aromatics are benzene, toluene, and xylene. These molecules are also present in gasoline. As a general rule of thumb, lower molecular weight hydrocarbons have lower boiling points, and higher molecular weight hydrocarbons have higher boiling points. This explains why the lower molecular weight alkanes are gases at room temperature and is an important property to consider during crude oil refinement. So, where does gasoline and crude oil come from, and what does petroleum mean? While these may seem like easy questions, it is important to understand the origins of crude oil so that we can compare its use as a fuel to other alternative sources. We will see later that common fuels like gasoline and diesel are very similar in structure to biofuels. A fossil fuel is any source of energy which has accumulated in the subsurface of the earth from prehistoric plant and animal deposits. Contrary to the previous image, fossil fuels are predominantly formed from the remains of ancient dead algae and zooplankton. Crude oil, coal, and natural gas are all examples of fossil fuels. Crude oil, also known as petroleum, is the end result of millions of years of thermal and pressure-induced decomposition of organic material. It is typically extracted from subsurface reservoirs in a liquid form, but can also be stripped from solid sources as well. Crude oil is composed of various hydrocarbons of differing molecular weight, and is generally useless in its natural state. It must first be refined before it can be used as an energy source. Gasoline isn't actually a single molecule, but is a mixture of lower molecular weight hydrocarbons, typically between 5 and 12 carbon atoms long. This is due to the refining process. Gasoline, as well as other fuel mixtures including diesel, are refined from crude oil in a process known as fractional distillation. In the fractional distillation process, crude oil is fed through the bottom of a distillation column, and different hydrocarbon mixtures are removed at different points within the column. The process takes advantage of the different boiling points of the hydrocarbons comprising the crude oil. The short video you're about to see details the distillation process of crude oil as it is fed through a column.
The thing about crude oil is it's crude. Even if you could get that stuff into your petrol tank and somehow set fire to it, it wouldn't provide the instant explosive power that internal combustion craves. To be honest, you'd be better off coating your driveway with it than driving with it. To become usable fuel, it has to be refined. So at the heart of the refinery lies the laboratory, headed by Joyce Bussey. It's up to Joyce's lab to supervise the process of turning the crude oil into usable products.
Crude oil in this state is not very useful at all. If you put this in your tank, you'd be sorry because it wouldn't go anywhere.
The trouble with crude oil is it contains a mix of hydrocarbons, each of which has a different number of carbon atoms. The hydrocarbons are different in weight. The lightest is propane, while the heaviest is used to make asphalt. Extracting petrol from this mix is a formidable challenge, and it requires one heck of a chemistry set to do it. The most important part of the plant is this. Like a moonshine still as tall as a cathedral, this is where the crude is separated. Heated to over 370 degrees Celsius, it's pumped into the base of the tower, and like steam from a kettle, the vapor rises. As it cools, the molecules condense, the heavy asphalt and tar at the bottom, while lighter molecules, including diesel, jet fuel and petrol, continue rising until they too condense and can be siphoned off.
Most of our consumable energy is produced through the use of non-renewable resources, specifically fossil fuels. These graphs from the United States Energy Information Administration, or EIA, illustrate the breakdown of renewable energy consumption in the United States by source. The EIA is a government-funded agency under the Department of Energy and compiles data from multiple sources on energy use within the United States. The graph on the left compares hydroelectric, wind, solar, and biomass energy sources. Biomass includes things like biofuels, biowood, and also waste from municipal and agricultural sectors. As you can see, renewable energy use in the United States has been slowly growing since the 1950s, and only recently have we seen the introduction of wind and solar technologies. Today, the U.S. is still mostly reliant on fossil fuel energy, using nearly 20 times the amount of fossil fuel as renewable, and 10 times that of nuclear and renewable energy sources combined. This finally brings us to the main focus of this lesson, biofuels. In the broadest sense, biofuel is the term used to describe energy stored as biomass. Unlike petrol fuels, biofuels utilize energy from recently living organisms, instead of energy derived from crude oil reservoirs. As a result, the production of biofuels is considered to be partly carbon neutral. To give you an idea of why this is, we will consider corn as an example. Corn stock used for biofuel production is grown in large quantities. Corn utilizes carbon dioxide, water, and light energy to grow, and in doing so, the plant builds biomass in the form of carbohydrate storage. The plant is then harvested, and its sugar is used in biofuel production. This biofuel can be used in vehicles and finally combusted, releasing CO2 and water back into the atmosphere. If only biofuel is used for energy purposes, this cycle will continue on. Combustion of fossil fuels is not considered carbon neutral because the carbon dioxide released from the burning of fossil fuels cannot be removed and reused in a similar way. Burning of fossil fuels releases an excess amount of CO2 into the atmosphere. As you can see, the burning of biofuels is deemed carbon neutral because any CO2 released into the atmosphere is accounted for in the growth of the feedstock. Of course, even if only biofuel were used, this process would still be imperfect. Can you think of some disadvantages to the use of biofuels? Take a moment to compare and contrast the advantages and disadvantages of using biofuels versus petroleum-based fuels. Pause the video and discuss your thoughts with the class. Biofuels are not a particularly new concept. With the invention of the diesel engine in the late 1890s, peanut oil could be used to move gasoline to power an engine. In a 1912 speech, Rudolf Diesel was quoted as saying, "The use of vegetable oils for engine fuels may seem insignificant today, but such oils may become, in the course of time, as important as petroleum and the coal tar products of the present time." It has only been recently, however, that biofuels are emerging as an alternative source of energy, which may compete in a consumer market against traditional petrol fuels. Methods of synthesizing biofuels using biomass materials are becoming more efficient as science and technology progresses. The two main types of biofuel are ethanol and biodiesel. For the remainder of this video, we will focus on the production of these two biofuels and their viability as sources of fuel. Ethanol is most commonly associated with alcoholic drinks and is commonly referred to as grain alcohol. Ethanol can be thought of as a biofuel equivalent to petrogasoline, but is about 60% the energy density of gasoline. This means that an equivalent amount of bioethanol will not produce as much energy as petrogasoline on a mass-to-mass basis. The raw feedstocks used for ethanol production include corn, wheat, sugar beets, sugarcane, molasses, cellulosic materials, and algae, but generally any feedstock with an ample supply of sugar may be used. In the United States, most bioethanol is produced using reserved corn supplies. Production of bioethanol is relatively straightforward and employs the same techniques that the spirit industry does to produce liquor. First, the feedstock, in this scenario molasses, is added to a fermentation chamber where yeast converts sugars to ethyl alcohol. Depending on the feedstock used, enzymes might need to be added in order to break down long-chain sugars into simpler sugars. Yeast can utilize simpler sugars more efficiently, so this step is necessary to ensure proper conversion of sugars to alcohol and within a reasonable amount of time. Next, the resulting mixture is pumped to a series of distillation columns to separate the residual particles and water from the alcohol. The end result is a highly pure ethanol product, about 95% ethanol by weight. Finally, the ethanol is pumped through molecular sieves to remove excess water and any impurities which may have passed through the distillation step. Condensate water from distillation is recycled back to the head of the plant to conserve water, and waste products from the unconverted molasses may be used as a food for livestock or burned to produce energy for the plant. Biodiesel, on the other hand, is a biofuel equivalent of diesel fuel. It is produced in a reaction known as transesterification. Vegetable or animal oil is reacted with methanol using a base catalyst to produce biodiesel and glycerin. Glycerin is a material used in soap making.
My name is Brent Baker. I'm the founder and CEO of Tri-State Biodiesel. We've been in existence about 6 years, and we've been collecting cooking oil in the city for about almost 4 years. We're here at our headquarters in Hunts Point, Bronx. This is our administrative offices as well as our rendering facility and truck depot. So this is the place where all the cooking oil that we collect in the city and in the region gets consolidated and cleaned up and then shipped out for biodiesel manufacturing.
We leave the office about 6 in the morning. We go to our first restaurant. We take the hose off the truck, run it down to the basement. Sometimes we carry the oil upstairs. We'll suck it up with the hose. Then we go to our next stop and do the same process. And we do that all day long. Then we head back to the Bronx And we got a big tank that holds like 6,000 gallons. We have 3 of them tanks, and we dump them into there. We take all the oil, because every oil makes a good biodiesel. Just have a longer process of cleaning it out.
Once they're done with the shift, they'll come in here and hook up to our incoming filtration system and load this raw cooking oil and fats through our system and into our raw oil storage tanks. Filtering out bits of French fries and chicken bones and whatever got into our truck. It's all organic solids, so it's actually good stuff for the mix of some fertilizers. We process somewhere around 6,000 or 8,000 gallons a day here at this facility. It works great as a heating oil. I mean, it's really the easiest application in the world.
So we take this waste product that at one point was either animal feed or landfilled, and we're making a sustainable fuel, something that instead of wasting it, throwing it away, we're making something that has a second life, a second use. Tri-State goes out and they collect the oil. Tri-State then will load that oil into a truck. That truck, which today we're using Hart, Hart will go and pick up the oil from Tri-State, deliver that to Northern Biodiesel. Our guys grab a sample, we test the quality, ensure that it is what it needs to be, then we just bring it into one of our holding tanks. Feedstock has a value based on what's in it. So the first thing we do is water testing and a free fatty acid testing. As you take any oil or animal fat and you cook it, you heat it up, by default, that oil will start to develop these free fatty acids. Those free fatty acids actually turn into a soap on us in production. So what we want to do is we want to eliminate that or have as small amount as possible. We take alcohol and our catalyst, we combine that with the oil. The oil and the alcohol undergo a chemical reaction in the presence of a catalyst. That oil actually will drop off glycerin and will be replaced with an alcohol. Our alcohol is a methanol, which makes it a methyl ester. That's the chemical name for biodiesel. From that point, it goes into a reactor vessel where that reaction takes place. The biodiesel then, free of that glycerin, will come off the top, we'll hit it with another 10% of what we need to force the reaction to completion, make sure we have a really nice, clean reaction. That reaction happens on a smaller scale in another reactor vessel. From that, we go into all quality. The quality consists of making sure that we get a really good wash, which removes a lot of impurities, metals, etc. And then the next step is a distillation. The distillation removes all of your free water, free methanol. At that point, you have a really nice, clean, spec quality biodiesel. Once it's in our finished holding tanks, we can either fill rail cars for customers or we can fill trucks. We can accommodate any customer, big or small. We wanted to make a New York connection for biodiesel. All of that feedstock is from New York. All the biodiesel is made in New York, and all that biodiesel goes back and is consumed in New York. And that's when we come back to that sustainability, that localized focus on what we want to do here, and that's collect and supply our customers a New York product.
We work with Tri-State Biodiesel, Northern Biodiesel, and Ultra Green Energy Services in Chicago. We wear 3 different hats. We own the bulk transportation company called Hart Trucking Corp. And Ultra Green Energy Services has hired Hart Trucking Corp to pick the raw product up, the yellow grease, and bring it back to New Hyde Park. We also own New Hyde Park Oil Terminal. New Hyde Park Oil Terminal is hired by Ultra Green Energy Services to offload that yellow grease and pump it into a rail car. When the product comes back as biodiesel, it is brought into New Hyde Park Oil Terminal, and our other company, Hart Petroleum, which sells heating oil and biofuels to the consumer, gets involved at that point. The product is loaded into a separate tank. It's maintained at a certain temperature so that when it's blended with either diesel fuel or with heating oil, we don't have to be worried about any type of product gelling up. It's all computerized, activated, so if a driver comes in and he punches into the computer, which is called an AccuLoad, he'll punch in what type of blend he's looking for. It blends, takes a certain amount of product from one tank and another tank, which would be 20% biofuel and 80% heating oil, and gives us a B20 mix. At that point, once the truck is loaded, he just goes about what his normal deliveries would be for the day, and just delivers it like he would be delivering regular heating oil.
We sell a lot of B20 heating oil. That's our main retail fuel business. It's 20% biodiesel mixed with 80% number 2. We don't have anybody screaming at us that seals are blowing up. We don't have any problems with gelling. People are scared, hey, if I change, I want to have my heater working. That's very important to keep my family warm. And so people are scared, and that's legitimate. But the fact of the matter is, that if those folks would talk to any of our customers or any of the customers of the other several companies in the area that sell bioheat every day, none of those customers are complaining at all.
In conclusion, a fuel is any material which stores chemical or nuclear potential energy. Fuels can then be later used to provide energy for different purposes. Hydrocarbons are energy-rich molecules, and most fuels we use are composed of different hydrocarbons. Biofuels are renewable sources of energy and are generally carbon neutral, while fossil fuels are not. Biofuels may be created with a variety of different feedstocks, which makes them an attractive source of alternative energy. Ethanol and biodiesel are the two main types of biofuel, and ethanol is produced through bacterial fermentation, whereas biodiesel is produced in a chemical reaction called transesterification.